Myself, I'm Somshakar. I'm continuing this lab 4 session. Uh, I'm discussing Taylor series expansion. Okay, so first I'll discuss this Taylor series. What is Taylor series expansion? F of x is equal to f of x naught plus x minus x naught f dash of x naught plus x minus x naught whole square divided by 2 factorial into f double dash of x naught and so on. That's called Taylor series expansion. Okay, so here we can write like this. Can put 1 factorial. Okay, so I'll take one example. Expand sin x Taylor series about x is equal to pi by 2. So you can put pi directly, pi by 2. Up to third degree term, also find sine 100 degree. So given f of x is equal to sine x and initial value of x is pi by 2. So consider f of x is equal to sine x. We'll find the at initial value. What is the function value at x naught? So let us change this x to x naught. F of x naught is equal to sine x naught and assign this x naught value pi by 2. F of pi by 2 is equal to sine pi by 2. Sine pi by 2 value is 1. So differentiate this with respect to x. So we'll get f of x differentiation is f dash x, sin x differentiation cos x. So we are assigning x value as x naught, f dash of x naught is equal to cos of x naught, and again x naught value we are assigning f dash of pi by 2 is equal to cos pi by 2, cos pi by 2 value is 0. So differentiate again the above step with respect to x. So we are getting f double dash on differentiation, we will get f double dash of x cos x differentiation minus sin x. So now we are assigning x value for x value as x naught. F double dash of x naught is equal to minus sin of x naught. So we are again assigning x naught value as pi by 2. F double dash of pi by 2 is from minus sin pi by 2 minus as it is sin pi by 2 is 1. Differentiate above function with respect to x again. So f double dash becomes f triple dash of x minus keep it as it is sin x differentiation cos x. So we are assigning x as x naught value, f triple dash of x naught is equal to minus cos of x naught. So again we are substituting x naught value as pi by 2, f triple dash of pi by 2 is equal to minus of cos pi by 2, cos pi by 2 value 0. So here we are said that up to third degree term, so it is enough. Now we have a Taylor series f of x is equal to f of x naught plus x minus x naught. Put 1 factorial into f dash of x naught plus x minus x naught whole square divided by 2 factorial f double dash of x naught. Okay, so what is f of x sin x? So we are just assigning the values of x naught, pi by 2, x minus pi by 2 by 1 factorial f dash of pi by 2, x minus pi by 2 is whole square divided by 2 factorial into f double dash of pi by 2 plus x minus pi by 2 whole to the power of 3 divided by 3 factorial into f triple dash of pi by 2 and so on. Put x equals 100 degree. We are changing this 100 degree into radian. So it is the conversion 100 into pi by 180 after cancelling. So we are getting 5 pi by 9. So 5 pi by 9 is nothing but 100 degree. So putting x value as 5 pi by 9 and simplifying, we get 0.9848. Now look into the program line. So the same one, import numpy. Here we required a numpy module. As from numpy, we are taken as a variable np. Import numpy as np from matplotlib dot from matplotlib import pyplot as plt. Matplotlib is a module. From that we are importing pyplot. So and from that pyplot we are taken a variable plt. From simpy import star. Here we required 3 modules. One is numpy module, matplotlib module, and simpy module. So here we required only one symbol, so that's why we have taken a capital S symbol. So more than one, we more than one symbol, just we taken as small letter S symbols. Okay, so symbol X stored in X, and we write the problem statement in program line. Y is equal to sine 1 into x. So this is sine. We can simply write sine x. So rather than 1 star x. So 1 star x is also gives same 1. So print y means get value. Just remove this hash symbol and just run sine x like that. So format x naught value is pi by 2, float pi by 2, as it is a decimal one, so it just take a float value here. So here we required first order, second order, and third order derivatives. So differentiate y with respect to x, that is stored in dy. Differentiate y with respect to x twice, that is stored in d2y. Differentiate y with respect to x 3 times, that is stored in d3y. We can remove this as symbol and then run. Sin x cos x minus sin x minus cos x like that. So now we write the Taylor series in program line. Y at x naught plus x minus x naught divided by 1. 1 factor means 1 into dy at x naught plus x minus x naught. Double star 2 means x naught x minus x naught whole square divided by 2. 2 factor means 2 at d2y at x naught plus x minus x naught whole to the power of 3 divided by 3 factor means 6 into d3y at x naught. So print simplify y. So it is simplified simplified step. Y at lambdify x. Lambdify means we are assigning x value to y. We are assigning x value to y. Okay. So defining just remove this hash and run. After lambdifying x, we are assigning x value to y. So what happens? It simplifies and gives 0.985, the total value of this. Okay, so we can plot this, define f of x that returns as sine x, np dot sin x. Why we are introducing np here? So return, just we write return sine x means it takes string value. So I will remove and I will run, so can understand. Now I just run. So there's the error you just took here. So immutable dense array object has no attribute as coefficient. Okay, so that is why. So we have put np. So now just run. It came. Okay, so x is equal to np dot linspace. Linspace you can take any much. I will take 100, then run. More number of what we call it as division. So it's uh, 1000 can run. So the peak of the curves is going to be very high. Okay, so we can't get a smooth curve. It's a almost a particular one. So that's why we are taken. So 10 only. Now you can run. So it comes a smooth curve. Okay, so plt dot plot x y at x color in red. So that is so what we are finding the Taylor series value. So that is come in the red color, and plt dot plot x f of x in green color. That is problem statement sine x. So sine wave. This is a green one is sine wave, and the y at x that is what we got the Taylor series value that is stored in here. Okay, so then plot y limits -3 to 3. You can change that this also. Plot dot grid. So we got a grid, and then at last plot dot show. It shows. Okay, so this is about Taylor series. Now I end up this